To preserve, restore, or investigate paintings has been always a delicate labor. My name is Javier Cortes Rosas, and I'm here today to talk about my new software, Anna, a new tool based in artificial vision to help to the restorers in the labor of preserving paintings. Now, to know the importance of Anna, we have to know some relevant points. Maybe one day you heard that everyone in the world is different, but in this case, that's true. Each and every one of us can see different quantity of colors, and that can influence in the time when you are restoring one paint, or when you want to know what is the palette that the artist or the author used to create that painting. But you can say, what is the main importance of all of this? Well, the other painting is the original paint, and the recently painting it's the new or the ancient restorations that made in this painting, and we want to see the original paint. Another important point is that technologies in this area are not updated. What I mean, technologies and tools are invasive. This means that will damage or compromise the structure or the body of the painting itself. Considering these points, the painting are going to suffer a lot of damage at the time to be restored or be investigated. That's why we have built Anna. Anna can analyze pictures of paintings under natural light, UV light, or infrared light. And this analysis will show the pigments or the colors that are inside of this paint. If we choose pictures, we are not going to damage the structure or the body of the painting. And we are going to draw the results that the restorers and investigators needs. But I consider if it's better if you see the software by your own eyes. Let's take a look to explain better the functionality of Anna. You can download here in our GitHub repository. You can see the link in the video description. You can choose between two versions of Anna. The first is the Spanish version and the second the English version.
Actually, exist two versions of Anna. Select the version according to your preferred language. For this example, we are going to use Anna English version. If you click in the links of the video description, you're going to redirect to these GitHub repositories. Now, all you have to do is to click here in the green button, Code, and select Download zip. Then you have to go to your download folder and drag this file to the desktop. Now you have to extract the folder inside in the desktop. Here is Anna. Now, it's important to remember to run Anna, we need some requirements. For that, please take a look of the README. Before to do any change in these files or windows of Anna, please read before the license. Now, once we have the folder here, we have to use our Spider software. Now we have to open just the Anna code and click here in the green flag or run. Now this is the main window of Anna. You can see here the two logos of the institutions who work together to create Anna. Now if you want to know more about the Anna, you can click here in the information button. Here you can find some information about the software. If you have any question or commentary, you can call this number or send a mail in this email. Now we have here two options. The first one will redirect you to another window. This window can analyze a picture and as a result will give us an image composed by two masks. The black mask it's the part of the image that have not this color that you select, and the white belongs to the color that you select. You have to charge one image. In this case, we are not upload any picture. If you make this, you are going to analyze the icon of Anna. You can see here the black mask is where it's not the color. I select red, so the parts where it's not the red are in black, while the parts in red are in white. Now, let's make it with another picture. As a test subject, we have the folding screen Battle of Vienna. It is a part of a folding screen that belongs to the Vice King here in the New Spain. With time, this folding screen was divided in two parts. One part is here in Tepoztlán in Mexico, and the other part is in the Brooklyn Museum in United States. Now, we have some photographs in UFV of the folding screen of Vienna. It's important to remember, to make this analysis, we have to upload some image with some characteristics. One of it is that the pixels must be of 5000 x 5000. For the example, we have a really full picture of the folding screen Battle of Vienna in UV light. So we have to part it. We have to divide it to accomplish with that requirements. We already have that pictures, so let's select one of it. Now, let's charge this. This is a part of the hunting scene. It's the other side of the Battle of Vienna. Now, let's make an analysis. As you can see, the UFV makes that the white color shines in blue. Okay? For that part, if we want to see this darkened blue, we can click here in blue. This is the result. The result is all the parts in blue now shining in white, and the black is where is not any part of blue. Just as they are arranged. As you can see here, we have two parts of blue, if you want to simplify this. One that is very clear, and someone that is something darker. Let's see. For that reason, we make a lot of categories of the colors. While blue detects all these stronger blue, the cyan will detect the weakest blue. Let's see. Here we can identify some parts of cyan. This part of the jacket of the man. And now let's see blue. Okay. This it's the part of the mother of pearls what shines with the UV light. As you can see here, you can see the details. Now, this is very simple. This window functions when you want to see all the areas that belongs of that color. I want to see what percentage of the blue color belongs to that part of the folding screen. That's that's really simple. But what if I want to see all the colors, all the range of color that I am detecting? Well, for that it's the second part. The second option is the original color. Now, if you already upload some image, the image is already charged here. If you use it in this window, you will use it in the other window. But if you want to change it, just click in the select picture. Now, we charged already an image before, no? Now we want to see it, the original colors. If you remember, it was cyan and blue. Let's see cyan. Here is the original color. This serves to see the range of colors that you are detecting. Now let's see blue. Now, how I said, maybe I can see just 3 colors here. And for me, this is blue, and this is some kind of white. For that reason, it's important to have Anna. Anna can detect and can be visual at the time of detecting colors. Anna can't detect what is part of cyan. Cyan, it's different of blue. Maybe for our eyes, it's not different. There is not any difference. But for Anna, are totally different. But how does Anna work? Now you can ask, how does Anna works? Well, if you know, pictures are often made by pixels composed by values of RGB, red, blue, and green. The combination it doesn't involve kinds of variables like saturation and value who. It's important at the time of analyzing paintings to have some concept present, like the varnish always gets darkened with the time. As you can see here in this graphic, maybe the original color is here, maybe a mango's color, but with time the varnish get older and the varnish get darkened, and for that reason, what it was a really cute yellow mangoes, now it's here like a really immature banana. Green, red, and blue just consider the shining colors, okay? While in HSV we can experiment and do tests with a lot of variables. So darkened colors, the really shining colors. Here we convert the RGB to HSV. But how we can establish the range of the colors that we want to detect? Well, that's simple. The pixels has some information. The information is the color that it's made. What I mean, in the case of RGB, the percentage of blue, green, and red. Here in HSV, we can give another kind of information. We can give saturation, hue, and value. That means that we can select one color and say if we want to get darken or give it shine. Okay? Now, for the color detection, maybe just can look simple. We use an NP array to create the starting point, and we use another NP array to create the stop point. Okay? And we do this with all the colors that we made. It's important to remember that we can use all the values as we want, but these specific ranges were defined by the restore of the National Museo del Virreinato. So these are ranges created by an expert.
Well, as you can see, Anna uses OpenCV and Python to analyze the pictures and show the color that you select. What is the use of this? With this, we eliminate all the human factor about to see the true colors, and not just that. If we take the pictures in the UV test or the infrared test, we are not damage the painting or the user, in this case the restore. That can help us to analyze the layers of the paint, to know the original layer and the most recently layer. With this, we can know the true story about the painting itself. But how we are defining these colors? Well, Ana is a project result of the collaboration about the Universidad Mexiquense del Bicentenario and el Museo Nacional del Virreinato. Here, the restored search building has defined all of these colors in HSV values. All we have to do was transform these HSV values to HSV Python values. And that's how Anna can detect all the colors that you need. Now, this is just a prototype of what is coming. We want to make a new project to make it this in a real time. We can put the light UV and we can analyze in a real time. If we are present at the moment of making the test of UAV or infrared, we can suffer some damage or we can compromise our health. If we can make it in a real time with a robot or with some kind of domotic, if we left the painting receive more UV lights, we are going to obtain a better result. If we can make it real time without compromise the user, we can obtain more information about the folding screens. Not just the folding screens, another pieces of art or even another Asian pieces. That's the main importance of Anna. This is just the beginning of the new age of tools in the restoration or research of Asian pieces. We are bringing the new technology not just for museums, we are bringing it to the restoration itself and investigation. That's the main importance of bringing this new technology. We can apply a lot of new tools to help this very, very novel labor that is preserved for heritage from the New Spain of the colony of the First Nations. We need to bring more, and this is just the beginning. This is just the base. We can apply more. As I said, you can apply robotic, domotic, and even in the future we want to make this with some AI or even recognition to identify all the mother pearls inside of the folding screen. All of this in the order of preservation and investigation. All of this without hurt of heritage. For my part, is all. I really think that it's a lot of things to say, but there's a little time. If you have any comments, you can leave it here in the commentary section, or if you want to contact me, you can read me inside the GitHub repository. In any version, you can see the contacts in the last part, my number and my email. And if you have any question, I'll be real pleased to answer it. Thank you very much for your attention and have a nice day.